All right, I'm Darryl Ford, and in this video I'm going to show you how to set up and check the alignment of an extruder barrel. The purpose of it is to align the barrel to the gearbox. In other words, this barrel, they mount it on here, and we want to ensure that it's in line with the axis of rotation of this gearbox. So we have a laser beam that we put in the end, we have a target that we put on the other end, and I'll explain that. But first off, we have the gearbox here, and we're going to put the laser in here, and we want to project this out so it's on this axis of rotation. When we first put it in here, there could be an angle. It could be coming out here like this. So I'm going to rotate that. Then it would be coming out like this, and I'm going to look at the readout, and I'll do some math, and I'll figure out what my set point is. And I'll adjust that so I'm on the axis of rotation. So that's a quick rundown of what we're going to do. I'm going to start out first by saying on the end of the gearbox, you have a see-through gearbox. Sometimes you have a large ID in there, and we're going to put a 3-jaw chuck in here. So we have 2 different sets of jaws for this chuck. We have ID jaws and we have OD jaws. So if I have a large enough opening, I'll put the ID jaws in and I'll put it in the ID. Sometimes it doesn't stick out far enough to get on the OD. This one does, so I'm going to use the OD jaws. And I take the chuck key and I mount this onto the gearbox and tighten the jaws. And I want to make sure that all of the jaws are up against the face of this nub, the rear of the gearbox. Then we'll put the 705 in there, and again, set these at the nominal settings. And then we'll put the battery pack on, and the battery pack is magnetic, so plug it in and turn it on. Now I should have a light coming out the other end of the barrel, which I do. I can see it on the wall down there. All right, now when I start, I like to just put a piece of paper on here and do a course alignment. In other words, I'll tape a piece of paper on the end of the barrel. And the object here is to get the laser beam so it's in the center of the barrel. But sometimes you're so far off you can't even hit the target, so you can't use the numbers. So I just tape a piece of paper on the end of the barrel, and I turn the laser into the inverted position. In other words, upside down, rotated 180 degrees from the normal position. And when I rotate this, we have to rotate the whole gearbox. Here I don't have any drive motor or anything on an actual extruder. You may have a belt drive and you'll have to use the belts. You want to turn the whole gearbox. You don't want to turn just the laser. You want to turn the whole gearbox with the chuck. So I turn it 180 degrees, and I'm going to take a magic marker, a felt marker, and I'm going to put a dot in the center of that laser beam. I can see the beam through the paper. Now I'm going to turn this back to the normal position. Now my dot will be in a different spot. So I'm going to take my marker and put a dot in the middle of the laser beam there. Then I'm going to take a tape measure, and I'm going to measure between those two. And I'm going to put a dot halfway between those 2 marks. So if I drew a line through those 2 marks, the dot would be right on the middle of that line. Now I'm going to adjust the laser beam so it's on that dot that I just made. This is a course alignment. It's always easier if you have two people, but one person can do it. Okay, a little more. Okay, that puts us on the dot. Okay, so now I have the laser beam on the dot. That's coarse aligning the beam. That just gets me so I'm pretty close to on the axis of rotation. I can take the paper off, and then we'll set up the target. This is the STA Adapter. This will fit bores from a 2 1/4 up to about 6 inches. We have an LTA, A-510 LTA adapter. We can start with this, a 4 1/2 inch bore, and go up to a 16 inch bore with this adapter. So we cover a pretty good wide range of barrels diameters. Just need to have the right diameter to get the right length of legs. We have on this adapter, we have two sides. There's a self-centering mode and there's a measuring mode. So when we're going to do the alignment, we want to put this in from the self-centering side. When we want to measure wear, we'll take the target out and we'll put it in from the measurement mode side. This target slides into the adapter, and there's a dowel pin here and there's a slot in the top of the adapter. We want to get that dowel pin in that slot. And then we have the set screws that we put in here to hold the target in place. So now we mounted the target into the adapter. Now we have to put the legs in. Now we have legs, depending on the size of the bore, you buy legs that fit the diameter of the bore. In other words, this is a 2 1/2 inch barrel, so I have 2 1/2 inch legs. So I have to have the target in there, and then I slide the leg in there and tighten the set screw against the legs. Okay, so now the legs are in there. And these legs are pushed up against the OD of this target. Now this is what we call a true self-centering target with no moving parts. In other words, these legs are a little bigger than the bore itself, so when I put it in, it's going to be at an angle. But you see how these legs are offset. They're offset, but right here in the middle where this pivots, that's where our measuring plane is at. That's where we measure at. So this can change its angle all day long, and it's always going to stay self-centered. So once we have the legs in, then we'll put the handle on the target. That just screws on there. And when we put this in the bore, we just gently pull back on this cable so that tilts down and it'll fit in the bore, and we'll release it and it'll lock itself into the bore and be self-centered. So I gently pull back, put this to the end and release the cable. It's going to lock itself in. We want the cable on the bottom. That's what we call the normal position, with the cable on the bottom. And then we'll take this and we'll plug this into the R1307 and turn this on. Okay, now these legs, you order these from us, these legs are set up for the nominal diameter. In other words, this is a 2 1/2 inch barrel. We have nominal legs 2 1/2 inches, or ground for a 2 1/2 inch barrel. So when we put this in here, if the barrel's nominal size, the target's pretty much straight up and down. If the bore gets bigger, this target's going to tilt back a little bit. If it gets smaller, it's going to tilt forward a little bit. But because it's pivoting here, this is where we're measuring, this can change its angle. It's always going to stay centered. So the barrel can get larger or smaller. Most of the time, if you're doing, using other equipment, some of our older equipment, we didn't have self-centering targets, so you would have to take a normal and an inverted reading and do the math to find the target error and calculate the diameter change. But this one, diameter can change and it'll always stay centered. Okay, then we have a level on the end of the pole. So when we have the cable on the bottom, make this level from side to side. The reason for that is when I move this in farther and farther into the barrel, I don't want that target to change its angle, so we'll keep the level from side to side. But now I've done a course alignment. I've done a course alignment with the paper. Now I have to fine tune this. So I'm going to look at my numbers here, and I have a -103 and a +36. The vertical number is -103. And the horizontal number is +36. The object here is I'm going to rotate this 180 degrees, and I'm going to add the two vertical numbers together and divide it by 2, so I get an average. That's going to be my vertical set point. I'm going to add the two horizontal numbers together and divide that by 2 or get an average, and that's going to be my horizontal set point. So now I'm going to turn this 180 degrees. And now I read +21 and +67. So now my vertical is +21, horizontal is +67. So if I add -103 and +21, I get -82 divided by 2, I get -41. So that's my vertical set point. Vertical set point, -41. Horizontally, -36, or +36, and +67, I get +103 divided by 2, I get +51.5, or I'm just going to make that 52. That's my horizontal set point. Okay, so I'm going to adjust the vertical and the horizontal micrometers until I'm -41 and I'm +52. Okay, I'm -41 and +52. I'm going to turn this 180 degrees. And now I'm -34 and 57, so I'm just going to do the math again. When you're off that far, you're going to have to do it a couple of times. So I had -41, I've got -34. Add that together, +75, or -75 divided by 2. We're going to say -38. Horizontally, I had 52, and I got 57. So I get +109 divided by 2. I'm going to say +55. So I want -38 and +55. So I'll do it again. 38. -38 +55. Turn it 180 degrees. -37 and 54. So I'm within half a thou. So 1 thousandths total, but the error is actually half of that. And because I rounded from 51.5, I rounded up to 52. So that's basically close enough. So what that's telling me is this end of the barrel is 37 thousandths low, and it's 55 thousandths off to the right. So it has to come at 53 thousandths. I have to raise this up, and I have to move it over in this direction. So normally on these, you have a V-block that this barrel sets in. So you can make these adjustments. So we just to loosen it up a little bit. Okay, so now I've adjusted the barrel, so I'm 0 horizontally and I'm minus 3 thousandths low. I always want to leave these a little bit low. The bigger the barrel, the more lower I want it. About a 6-inch barrel, I want about 10 thousandths low when it's cold. The reason for that is this barrel is going to grow in diameter as it heats up. So we figure a 6-inch barrel is going to raise up about 10 thousandths. This 2.5-inch barrel, 2 or 3 thousandths. We'll put it right in line when it gets hot. So now I can move this. Sometimes you have an adjustment point in the middle like I have here. Some barrels don't have that. But if you want to measure it, you can simply move this barrel in, or this target in, to about the adjustment point there, and using the level, we want to make sure we have the target oriented right. And we can see there we're 8 thousandths low and we're 3 thousandths to the right. There's not a lot I can do because this adjuster simply isn't working. But I can push this all the way into the feed throat. All the way up to the feed throat. And I can see at the feed throat, I'm 9 thousandths low and I'm 3 thousandths to the right. So on an actual extruder, there is no adjustment at the feed throat. It's piloted there. I would have to usually break that barrel loose there and retorque it. That's normally where the problem is at. They haven't torqued it properly. So that's pretty much how you do an alignment. Now, if we want to do measurements, then we'll take the target out and we'll put it in from the other side, and we can do wear measurements. So let's go ahead and do that.